Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we're going to look into part 2 of lecture topic 4, matrices and system of linear equation, with subtopic of 4.2, determinant of matrices. Okay. At the end of this topic, students should be able to find the minors and cofactors of a matrix and find the determinant of a matrix. Okay. So class, this thing that we call your previous knowledge, your prior knowledge that you have learned it before. So for the matrix of 2 times 2 with a size of 2 times 2, so then this sign is called sign of relative determinant in this topic of matrices. Determinant of A with a matrix of A, element of A, B, C, and D. Okay, so we call multiply with the element of A, the element of A multiply with D minus B multiply with C. So for example, if we have a matrix of A, so let's say we have a matrix of A, 3, 5, 1, -1. So then determinant of A, okay, determinant of A equal to this, and 3 times -1 equal to -3 minus 5 times 1 equal to 5 and equal to 8, -8. Okay, so let A be the n multiplied with n size of matrix of A. Okay, so the minor of Mij is a determinant of n minus 1 multiplied n minus 1 matrix obtained by deleting. Okay, this is the key word of the for minor, which is deleting the ith row and jth column of A. So this is a matrix of A, for example. Okay, so to find the determinant of find the minor of 2, 1. So 2 we call is the row number 2 and 1 column number 1 here. So for row 2 and column number 1, they will meet at this. Okay, the element of A 2, 1. So minor of 2, 1 equal to, we delete the second row and the first column. So what you see here now is element of A12, A13, A32, and A33. So this is it. Okay. So multiply between this A12 with A33 and A13 with A32. Okay. So this is the basic knowledge of to find find the minor of the matrix 3 times 3. And cofactor Cij is an element of Aij. So cofactor is a multiplying of -1 to the power of I plus j and the minor of ij. Okay, for example, okay, so I made a mistake here, sorry. Because the element of A11, so to find the minor of 1, 1. Okay, sorry then. Okay, so for minor I11, row 1, we delete the element in row 1 and column 1. Delete the element in column 1. So what you see here now, we have 4, 2, 4, 3. Okay, 4, 2, 4, 3. So 4 times 3 equal to 12 minus 2 times 4 equal to an 8. So 12 minus 8 equal to 4. And minor of 3, 2. minor of 3, 2. Okay. This represent row number 3. So we delete the element in row 3 and column 2. So what's left here now? We have 1, negative 1, 3, and 2. So 1, negative 1, 3, and 2. So 1 times 2 equal to 2 minus negative 1 times 3 equal to negative 3. So negative become positive. So 2 plus 3 equal to 5. Okay, so now this is the minor cofactor. Okay, to simplify this, to make all of you recall, to make us simply remember to record the sign of positive and negative, just assume that, okay, for this one here now, this is the element of a 1, 1. So just imagine that if this is negative 1 to the power of 1 plus 1, which is equal to 2, so negative 1 square equal to 1, positive. So we got positive here. And this is element of 1, 2. So for this one with negative of 1 plus 2, so 1 plus 2 equal to 3. So negative 1 cube equal to negative 1. We are negative here. So the pattern of this is negative, positive, positive, negative, positive, negative, positive, negative, positive, negative, and positive. So to simplify this, to find the cofactor of C11, which is negative 1 to the power of, okay, 1 and 1. I recall I showed you just now. Negative 1 to the power of 1 plus 1, which is 2. Negative 1 square equal to positive 1. So 1 plus 1. And the minor here is 4. So this is 2. Negative 1 square is positive 1. So 1 multiplied with 4 equal to 4. So for C32 equal to negative 1 to the power of 3 plus 2. And the minor is 5. So 3 plus 2 equal to 5. Negative 1 to the power of 5. Okay. We call third row and second column. Third row and second column. This is it. Okay. So negative 1 to the power of 5 is negative. There you go. So negative 1 multiplied with 5 equal to negative 5. Get it? Okay, so next. So the cofactor, okay, the minor of matrix. Minor, every single element, we can find the minor of each. Okay, so minor M11, M12, M13 until minor of M33. And when we multiply with the negative 1 to the power of, okay, because this is what we call the position of row number 1 and column number 1, 1, 1 here, so it is negative 1 to the power of 1 plus 1. Okay, let's take a look at this one here. It is located in the second row and the first column. So negative 1 power of second row plus with column number 1. So 2 plus 1 equal to 3. So negative 1 to the power of odd numbers. Yes, it is negative 1. Okay. And multiply with the minor. So every single negative 1 of this multiply with every single minor. Then it will give you the cofactor. Okay. So you can see here now the pattern of the sign. The pattern of the sign, which is positive, negative, positive, negative, positive, negative, positive, negative, and positive. So let the matrix of A here find all the minors of A, hence form the matrix of minor of A and cofactor matrix of A. Okay, solution here. Okay, this is the matrix of A. Okay, we get 1, 2, 0, 3, 1, 1, and 2, 0, 3. Okay, so we're going to find out the minor one by one. Okay, so M11 plus highlighter this. Okay, M11 meaning the first one here represent the row, which is row number 1, and the second one is represent the cofactor, we call the column. So we delete row number 1 and column number 1. So what's left here now? We got 1, 1, 0, 3. Okay, 1, 1, 0, 3. So then 1 multiplied with 3 equal to 3 minus 1 minus 0 equal to 0. Then it is equal to 3. M12. Okay. M12. So we delete row number 1 and column number 2. So what's left here now? We got 3, 1, 2, 3. Okay, so this now minor, we call the minor of 3, 1, 2, 3. Then it is now 3 times 3 equal to 9 minus 1 times 2 equal to 2. So 9 minus 2 equal to 7. Next one. So we delete row number 1 and column 3. Then minus 1, 3 equal to 3, 1, 2, 0, 3, 1, 2, 0. So 3 times 0 equal to 0 minus 1 times 2 equal to 2. It is now equal to negative 2. So now class, we'll find out the minor for the first row. Okay, minor for the first row with every single column of column 1, column 2, and column 3. Right now, okay, before that, we're going to find the minor of 2, 1. Okay, I'll write down here, straight here, and 2, 2, and 2, 3. Okay, so all with the row number 2, row number 2, row 2, and row 2. So I plan to clear earlier for row number 2 here, and one by one with row number 1. So then, we'll see here now, what's left? We got 2, 0, 0, 3. So determiner of 2, 0, 0, 3. So 2 times 3 equal to 6 minus 0 equal to 6. Okay, next. Let's erase this. Okay. Then we go to the second column. So then, we'll see here now, we got 1, 0, 2, 3. 1, 0, 2, 3. So then we get 1 times 3 equal to 3 minus 0 times 2 equal to 0 equal to 3. Okay, next. Delete element in row 3. So you see now, this what's left here now? We get 1, 2, 2, 0. 1, 2, 2, 0. 1 times 0 equal to 0 minus 2 times 2 equal to 4, and it is negative 4. So we got 6, 3, and negative 4. Okay, then delete this and this. We go to the minor of 3, 1, minor of 3, 2, and minor of 3, 3. So then, okay, so there you go. Okay, so we come up with this one highlighter, all with the row 3, row 3, row 3. So I delete row 3 here. And then begin with column number 1. So what you see here now? What's left here now? We get 2, 0, 1, 1. 2, 0, 1, 1. So then 2 times 1 equal to 2 minus 1 times 0 equal to 0. That is equal to 2. Okay. Then we delete the second row. So what's left here now? We got 1, 0, 3, 1. 1, 0, 3, 1. So 1 times 1 equal to 1. Minus 3 times 0 equal to 0. And it is equal to 1. Okay. And then next, oh no, sorry. Okay, delete element in row 3. So what's left here now? We get 1, 2, 3, 1. 1, 2, 3, 1. So 1 times 1 equal to 1 minus 2, 3 times 2 equal to 6. Then we get negative 5. So now guys, girls, we're complete. Find all the minor of equal of these matrices of A. So we're going to write down okay, sorry then. Okay, so determinant, okay, no. The minor of A equal to, okay, so we got 3, 7, negative 2, 6, 3, negative 4, and 2, 1, negative 5. Okay, let's see if I can write it here. So then minor of A, first we got 3, 7, negative 2. 3, 7, negative 2. 6, 3, negative 4. 6, 6, 3, negative 4. And 2, 1, negative 5. 2, 1, negative 5. Okay, 3, 7, 2. 6, 3, negative 4. 2, 1, negative 5. Okay, so now cofactor of A equal to, okay, remember this, the sign of positive, negative, positive, negative, positive, negative, positive, negative, positive. So the cofactor, just imagine that if 3 then multiplied with the sign of positive 1 here, so 3 times positive 1 equal to 3. 7 multiplied with negative 1 equal to negative 7. Negative 2 times positive here equal to negative 2. 6 multiplied with, 6 multiplied with negative, we got negative 6. 3 multiplied with positive here equal to 3. And negative 4 multiplied with negative. So negative 4 times negative equal to positive 4. Okay. Then 2 multiplied with positive, it give you 2. 1 multiplied with negative, give you negative 1. And negative 5 multiplied with positive here equal to negative 5. So this is the cofactor of A, 3, negative 7, negative 2, negative 6, 3, 4, 2, negative 1, negative 5. Okay. Okay, so this is the conclusion of the minor and cofactor. So then the cofactor expansion. Cofactor expansion along the ith row. Let A be the n times n matrix with entries of A, I, J for any I, 1, 2 until the n. Then we have the semicolon. This as a determinant of A is a summation of the element of Aij with the cofactor of Ij. Okay. So if A equal to the matrices of something like this, A11 and all here, by expanding along the first row, okay, the first row here. So A11 here multiplied with the cofactor of 1, 1. A12 multiplied with the cofactor of A12 and A13 here multiplied with the cofactor of 1, 3. So look at this one here now. A11, A12 and A13 is the element in the first row. Okay. So let's find out this one here now. Okay guys, I'm sorry. Because my explanation over my right what I wrote here is expansion along the first row, but according to the question it's the first column, so I make a mistake there, sorry. Okay, along the first column. So we can look at that 3, 1, and 5. Okay, so 3, 1, and 5. First, we're gonna write down, okay, A11, A21, A31. This is element of A21. And 3 and A21 and A31. Okay. Okay, so now for determinant of A, okay, this is a determinant of A here. Expansion in the first, we call along the first column. So we're going to find out the minor of 1, 1, minor of 2, 1, and minor of 3, 1. So first, for M11, so we delete the first row and the first column. Okay, because we are dealing with the first column here, meaning column 1 here and here and here is remain. So what changed after this is we're going to delete row number 1, then next is row number 2, then next is row number 3. So now, for minor of this, we got negative 2, 7, negative 1, 10, negative 2, 7, negative 1, and 10. So negative 2 times 10 is negative 20 minus 7 times negative 1 equal to negative 7. So negative times negative is positive here. So negative 20 plus 7 equal to negative 13. Okay. Then next, delete the row. Then we delete the element in second row. So now we got negative 1, 4, negative 1, 10. Negative 1, 4, negative 1, 10. So negative 1 times 10 equal to negative 10 minus 4 times negative 1 equal to negative 4. So negative times negative become positive. So negative 10 plus 4 equal to negative 6. Okay. Then next, we delete the element in row 3. Okay, so what's left here now? We got negative 1, 4, negative 2, 7. So then the minor here is negative 1, 4, negative 2, 7. So negative 1 times 7 equal to negative 7 minus 4 times negative 2 equal to negative 8. Negative, negative, positive. Negative 7 plus 8 equal to 1. So now, the element of A11. Okay, before that, we delete every single sign that we have here. Okay, element of A11, which is 3, multiplied. Okay, class, this is minor, and please remember that we have this pattern here: positive, negative, positive, negative, positive, negative, positive, negative, positive. So this is minor of M11. M11, we have sign of positive here. So negative 13 multiplied with positive, negative 13, plus with A21, which is 1. And this is a minor of 21, which is negative 6. And the sign of 21 here, we have negative. So negative 6 multiplied with negative equal to positive 6. And then A31, which is 5. Multiplied with, okay, the cofactor of 31. This is the minor. Negative 7 plus 8 equal to 1. So 1, we call the minor of 31 with a sign for 31 here, which is positive. So positive 1 multiplied with 1 equal to 1. Okay. So 3 times negative 13, negative 39, plus 6 plus 5. So 39, negative 39 plus 6 plus 5 equal to negative 28. Okay. Okay, so find the determinant of A by using the expansion of cofactors. Okay, the hints here: choose the row or column that has the most zero. So class, in this example, we like to suggest to you, if given to you a matrix of A 3 times 3 with an element of entries or element of 0, 0, 0 here, we do strongly suggest to you to choose the row or column that has the most zero, because when we have the minor, whatever the value of minor it is, multiplied with the entries of 0, element of 0, everything will equal to 0 straightly. Okay, so let's take a look at this. Okay, so now Let's recall, write the matrix again. Recall the matrix of A again. A equal to 2, -1, -3, 0, 0, 1, and 0, 5, -4. Okay, so you may choose either column 1 or row number 2. Okay, you may choose expanding recall cofactors using column number 1 or row number 2, because we have 0, 0 here in row number 2, and also column 1 we have 2, 0, and 0. So let's say determinant of A, I choose expansion in row 2. Okay, row 2, the element of here is 0 multiplied with cofactor of 2, 1, plus with another 0 with cofactor of 2, 2, plus with 1 and cofactor of 2, 3. Okay, so you just name it 0 and -1 to the power of 2 plus 1, and may call the determinant here minor here. When we delete second row and the first column, so we got -1, -3, 5, -4, -1, -3, 5, -4, plus with another 0 here, and -1 to the power of 2, 2. So 2 plus 2. And for this one, we delete okay, not that one side actually. Okay, we delete the element in second row and second column. So what's left here now? We got 2, -3, 0, -4. 2, -3, 0, -4. And then plus with okay, so for this one here now, and then plus with 1 and cofactor of 2, 3, -1 power of 2 plus 3, and we 2, 2, 1, 2, 2, and 2 with a column of 3 here. So we get now 2, -1, 0, 5. 2, -1, 0, and 5. So class, just now I did mention to all of you, we choose the row or column with the most of zeros because any cofactor multiplied with a 0, it will turn into 0, right? So right now we just assume that this is 0 and this is another 0. So we may just focusing on this one part only, which is 0 plus 0, and then -1, -1 power of 2 plus 3 equal to 5. -1 power of 5 is negative. And then for this one here, 2 times 5 equal to 10 minus -1 times 0 equal to 0. So then it is 10 here, -10. Okay. So let's have a look at the properties of determinant here. Determinant of A transpose equal to an A. Determinant of A multiplied with B equal to determinant of A multiplied with determinant of B. And determinant of K, any scalar multiplied with the matrix of A, equal to K to the power of N determinant of A. And where K is a scalar and N is the order of matrix A. If the corresponding elements are equal, if the corresponding element are equal in any two row or column in the matrix A, then determinant of A equal to 0. And if any two row or column interchange in the matrix of A, then the new determinant is negative A. Okay, so element in we call rules number 4 and number 5. We're gonna look this in next example here. Okay, now first, by using the properties of determinant, find A, we call determinant of A transpose if determinant of A equal to 10. Okay, so let's see the rules here. Okay, determinant of A transpose equal to determinant of A. So find determinant of A transpose. So we come at conclusion that determinant of A transpose is also equal to 10. Okay. Then next, find determinant of A, B. If determinant of A equal to 10 and determinant of B equal to negative 2. So let's see again. Determinant of AB equal to determinant of A multiplied with determinant of B. So class, conclusion here. It is also determinant of A multiplied with determinant of B equal to 10 multiplied with negative 2, which is equal to negative 20. No, sorry. Equal to determinant of A, B for this one. Okay, so the next, find this determinant of this if determinant of A equal to 10. Okay, class. For question C, okay, we compare with this matrix of A and this one, determinant of X for Y. Okay, this is for question C here. X for Y, 1, 3, negative 2, and W for Z. What's the difference between these two? Look at this one, X1W, X1W. We call the first column is remain, nothing changed. But look at the second column. The original question of A here is Y, negative 2Z. But we call it change it from column 2 to here, column 3. And 4, 3, 4. 4, 3, 4 from column of 3 here is an interchange, change to column of 2. Meaning there's an interchange between column 2 and column 3. So let's take a look at what the rule says about this. If any two rows or column interchange in matrix A, then the new determinant is negative determinant of A. Negative determinant of A. So then, what is our conclusion then for this? Then for this one, interchange between C2 and C3 here. Okay. It changed to column 3, and this column 3 interchange into column 2. So it is now determinant of this. It become, okay, for this one, wait. Okay, never mind, because this video is recorded, so I do believe a lot of you know how to overcome this situation here. So determinant of X1W 4, 3, 4 Y negative 2 and Z. This is negative of determinant of A, where determinant of A equal to 10, so it is negative 10 now. Okay, so interchange between two rows and column, it will give you a negative of determinant of A. Okay, so next one then, find determinant of A if x equal to W and y equal to Z. Okay, this is solution for question C. Let's say if I just solve this in one page here. Okay, so let's say if x equal to W, y equal to Z. So then now, if A, the new A is x, y, 4, 1, negative 2, 3, x equal to W. So x equal to an x and y equal to Z, y and 4. Okay, so what the rules says? If the corresponding elements are equal in any two row or column in the matrix A, then the determinant of A equal to 0. Okay, so let's take a look at this. We got x, y, and 4, and also x, y, and 4. So this element in row 1 and row 3 are equal. So the rule says that if the corresponding element are equal in two rows or columns, then the new determinant, we call then the determinant of A equal to 0. So we call the element in first row and row 1 and row 3. Row 1 equal to row 3. So then determinant of A equal to 0. Okay, this is for solution D. Okay, so these are we call the notes that I read earlier. So let's try yourself with this exercise. Find the minus and cofactors of A to 1. We got answers is 10 and negative 10. And also question number 2. Okay, it's an exercise, right? So I just leave it to all of you to try, referring to the examples that we were discussed just now. Okay, I'm not going to discuss much about this, or you may bring this methods into your tutorial class. So that's all for today. Thank you very much. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.